Hello and welcome to Mathematical Coaching Center. Today in this video we'll be seeing few application related to theorems of a circle. So this is the third part of the video, and if you have not seen the first two parts, the link will be given in the description. But before we begin, my name is Umang Khawas, and if you have any problem in learning mathematics, then consider subscribing this channel. So without any further delay, let's begin. So in the previous two videos we proved two theorems. Let's try and recall what did we prove. So in the theorem we proved that if AD is equals to BD, that means if this OD bisects this chord AB into two equal halves, that means AD is equals to DB. Okay, at that time this line OD will be perpendicular to AB. This line will be perpendicular to AB. And in the next theorem, what we did was, if this line was perpendicular, then we proved that AD will be equal to BD. That means this line will bisect this chord into two equal halves. Okay, so if it bisects, it will be perpendicular, and if it is perpendicular, it will bisect the chord. So we will use this result and try to calculate few things. So what are the things that we'll be calculating is we'll be calculating the length of the chord. Next we'll try to calculate the distance of the chord from the center, that is this length here, OD. This is the distance of the chord from the center. And what is AB? AB is the length of the chord. Okay, this is the chord. From here to here it is the length of the chord. And the third one is the radius or the diameter. We'll be finding out the length of the radius or the diameter. So diameter is a line that touches 2 points of a circle that passes through the center. So this is the diameter. This line here is the diameter, and the radius is from here to here. Okay, from the center to the point on the circle. So this is the radius. This is the radius, and this is also the radius. From here to here it is again radius. So we can say that diameter is twice the radius. So 2r is equals to d. So this is the formula for diameter, that twice the radius will be the diameter. Or taking 2 onto this side, we can say radius will be half the diameter. Okay, so these are basic formulas that we know. So now how do we calculate this three things? Okay, so we'll be drawing our diagram something in this manner. So we'll draw the radius joining O and A. Okay, this will be the radius, and we'll join O and B, and this will be the other radius, and this is perpendicular because it bisects this chord into two equal halves. Okay, so AD and BD is equal here. Now we'll be using Pythagoras theorem in this two triangles because they are right angle triangle. So we will be using Pythagoras theorem. Okay, so Pythagoras theorem says that hypotenuse square is equals to base square plus perpendicular square. This is the Pythagoras theorem, and we'll be using this theorem in this two triangles. Okay, you can use in either of the two triangles. Suppose if we use this in this triangle, that is OAD, then we have OA square is equals to AD squared plus OD squared. Okay, so OA squared, that is the hypotenuse, AD squared, that is the base, and OD is the perpendicular, so OD squared. Or you can use in this triangle also. So we'll have OB squared, that is the hypotenuse, BD squared, that is the base squared, and OD squared, that is the perpendicular squared. So this is how we use Pythagoras theorem in this diagram. So now here what we will be doing is, out of these three unknowns, two will be given to you. You need to find the third one. Okay, using this theorem. So let's try and solve few problems now. So let us see the first problem. The first problem says a chord of length 48 centimeter is drawn in the circle of radius 25 centimeter. So the length of the chord is 48 and the radius of the circle is 25 centimeter. Calculate the distance from the center of the circle. Okay, here AB is given as 48, that is the length of the chord, and the radius will be joining O and A. So this will be the radius here, that is given as 25, and this OD is the length that we need to find. Okay, so this is the question mark here. So let's write the given part. So solution, given the length of the chord AB is given as 48 centimeters. So this whole length from A to B is 48 centimeter. So what will be the length of A to D? It will be 24 centimeter. That is 48 divided by 2. So after cancellation you will get 24. Now we'll be joining O and A. So we'll be joining O and A, and what is this? This is the radius. So it is 25 centimeter. So we have a right angle triangle here. So we'll be using Pythagoras theorem. So Pythagoras theorem says that hypotenuse square, that is OA squared, is equals to base is AD squared plus OD squared, that is the perpendicular. So we'll put the values of OA and AD. OA is given as 25 and AD is given as 24. So we have 25 squared is equals to 24 squared plus OD squared. So 25 squared is 625 and 24 squared is 576. We'll be taking 576 onto the side. So we'll have 625 minus 526 is equals to OD squared, or 625 minus 576 will give us 49, and this is OD squared. So we'll be square rooting both the sides. So square rooting this and square rooting this, will have the square and square root will get cancelled out. So we'll have squared 49 is equals to OD. Now what is the square root of 49? It is 7. So OD is equals to 7 centimeter. So the length of O to D is given as 7 centimeter. So this is the distance from the center of the circle. This is the distance from the center of the circle to the chord. Therefore the distance from the center is given as 7 centimeter. So this is how we solve this kind of problem. So let us see one more example. So here we need to calculate the length of the chord which is at a distance 6 centimeter. So this chord is at a distance 6 centimeter. That means OD is already given as 6 centimeter. From the center of the circle of diameter 20 centimeter. So here diameter is given and the distance from the center is given. So solution given. So OD is given as 6 centimeter. The diameter is given as 20 centimeter, and we know that diameter is double the radius. So radius will be half of the diameter. So divided by 20 divided by 2 will give us 10. So radius is 10. So it is OA. So we'll be joining this. So this is OA is equals to 10 centimeter. So again we have a right angle triangle here. So OAD. So we'll be using Pythagoras theorem here. Now hypotenuse squared is equals to base squared plus perpendicular squared. So we put the values of OA and OD. So this is 10 squared is equals to AD is AD only and OD is 6. So 6 squared. So 10 squared is 100. AD squared is AD squared plus 6 squared is 36. So we'll be taking 36 onto this side. So we have 100 minus 36 is equals to AD squared. So now AD squared is equals to 64 because 100 minus 36 is 64, and again we'll be square rooting both the sides. Square rooting both the sides, we have square root of 64 is equals to AD because square root and square will get cancelled out. So we have AD. So what is the square root of 64? It is 8. So AD is equals to 8 centimeter. So we got the distance length from A to D as 8 centimeter, and we know that AD will be equals to DB. So if this is 8, this will again be 8, or we can say that AD will be twice of AB. So AB will be twice of AD. So AD is 8. So 2 into 8 will give us 16. So what is the length from A to B? It is 16 centimeter. So therefore the length of the chord is 16 centimeter. So this is how we find the length of the chord. So here also we used Pythagoras theorem. We'll be making the same kind of diagram and use the Pythagoras theorem. Okay, let's move on to next example. So here it is given the chord of length 16 centimeter is at a distance 6 centimeter from the center of the circle. Suppose this AB is the chord of length 16 centimeter. Okay, this A to B is 16 and this is at a distance 6 centimeter from the center. So this is 6 centimeter. Okay, this is 6 centimeter. Now we need to find the length of the chord, okay, of the same circle which is at a distance 8 centimeters. So we need to find the length of the another chord. Okay, so find the length of the another chord because this chord is already given as 16. So we need to find the length of the other chord of the same circle. So the circle is same and which is at a distance 8 centimeter from the center. So we are doing something like this. So if this O is the center, so this distance from the center is given as 8 centimeter here, and we need to find what is PQ. So here we'll be having two right angle triangles. So if there are two chords, that means there will be two right angle triangles. So we need to use Pythagoras theorem twice. Okay, so now here we have AD, the length is given, and OD is also given as 6. Okay, here the distance from the center is given, but the length of PQ is not given. So we need to find the length of PQ. To find the length of PQ, we need to know the radius. So to find the radius, we'll take the help of this lower triangle. So we'll be joining this and we'll find the radius. Okay, so we'll be using the radius to find the length of PQ. Okay, so let's start. So we'll write the solution. So what are the things given? The length of AB is given as 16 centimeter. If AB is 16, so what will be AD? It is half of 16, that is 8. Now OD will be 6 centimeter. It is given that this 16, the chord whose length is 16 is at a distance 6 centimeter, so this is 6 centimeter. So we'll find the radius, that is OA. So by Pythagoras theorem, using Pythagoras theorem on this triangle, so we have OA squared is equals to AD squared plus OD squared, hypotenuse squared is equals to base squared plus perpendicular squared. So OA is equals to 8 square, AD is 8 and OD is 6 squared. So OA squared will give us 8 squared is 64 plus 36. So this will give us 100. So square rooting both the sides, we have OA is equals to under root 100. So what is OA? OA is 10 centimeter. So what is OA? OA is the radius of this circle. So now we know that the radius of this circle is 10 centimeter. So now what we will do is, now see here, this PQ is here, this distance from the center is given, and we will be joining O and P. So we will be using Pythagoras theorem on this triangle and we'll try to find the length of the chord. Okay, so radius is 10 centimeter, so that will be OP, and again OR is given as 8. The distance from the center is already given as 8 centimeter. Now we need to find what is PR. So we'll be using Pythagoras theorem. OP is the hypotenuse, PR is the base, and OR is the perpendicular. So hypotenuse squared is equals to base squared plus perpendicular squared. So OP is given as 10 and PR we don't know the value, OR is 8. So 10 squared is 100 and 8 squared is 64. So we'll be taking 64 onto this side. So we'll have 100 minus 64 is equals to PR, and we have 100 minus 64 as 36 is equals to PR. So square rooting both the sides, we have square root of 36 is equals to PR, and PR is equals to 6 centimeter. So the distance from P to R is 6 centimeter. So this is 6 centimeter. Okay, now we know that again from R to Q it will again be 6 centimeter, or we can say PQ, the length of PQ will be double the length of PR. So PQ will be 6 into 2, that is 12. So this is the length of the chord. Okay, so we can say we have the length of the chord is 12 centimeter. So this length of this chord is 12 centimeter. So this is how we find the length of the other chord also. So now moving on, let's see the last example. The last example says, in the adjoining figure, AB and CD are two parallel chords. So AB is one chord, CD is another chord, and they are parallel. And O is the center. So this point O is the center. If the radius of the circle is 15 centimeter, find the distance MN between the two chords of length 24 centimeter and 18 centimeter. So this length is given as 24 and this length is given as 18, and we need to find the length from M to N. So this is the length that we need to find. Okay, so first the thing that we know is the radius of the circle is 15 centimeters. So let's write that. So solution, given the radius is equals to 15 centimeter. So we'll join O and A. So this will give us the radius, and joining O and C we'll also get the radius. So both O and A and O and C is of length 15 centimeter. They are the radius of the same circle. So now we have a right angle triangle here and a right angle triangle here. So what is AB? AB is given as 24 centimeter, and what will be AM? AM will be half of AB, that will give us 12 centimeter. Again, what is CD? CD is given as 18 centimeter, and what is CN? It will be 9 centimeter. Okay, now we'll be using this triangle, okay, AOM, and we'll be using Pythagoras theorem on this right angle triangle. So by Pythagoras theorem, OA squared is equals to AM squared is equals to OM squared. So OA is the hypotenuse, AM is the base, and OM is the perpendicular. So this is by Pythagoras theorem. So what is the length of OA? OA is given as 15 and AM is given as 12 centimeters. So OA is 15 squared and AM is 12 squared. So we'll have 15 squared is 225 and 12 squared is 144. We'll be taking 144 onto the side. So we'll have 225 minus 144 is equals to OM squared. So 225 minus 144 will give us 81, and that will be OM squared. So square rooting both the sides. So square rooting both the sides, we have something like this. This square and square root will get cancelled out. So square root of 81 is 9. So OM is equals to 9 centimeter. So this length here from O to M is 9 centimeter. Okay, now we'll again use the same Pythagoras theorem on this triangle OCN. So this length here is 9. Okay, and we'll be using Pythagoras theorem on this triangle here. So we'll have OC square is equals to CN squared plus ON squared. So this is OC is the hypotenuse, CN is the base, and ON is the perpendicular. So putting the values, we have 15 squared is equals to 9 squared plus ON squared, because this CN is 9, OC is 15. So 2 to 5 and 9 squared is 81. So taking 81 onto this side, we have 2 to 5 minus 81 is equals to ON squared, and 25 minus 81 is 144. So square rooting both the sides, like this. So we have ON is equals to 12 centimeter. Okay, we'll have to write OR here. Okay, OR and OR. So this length ON we got as 12 centimeter. Now what we'll do is we'll have to find now MN. So what is MN? MN is nothing but it is the sum of OM and ON. See, the whole of MN is the sum of OM and ON. So what is OM? OM is 9, and what is ON? It is 12. So adding this two, we get 21. So what is the length of mn, it is 21 centimeter. So this is how we solve this kind of problems. I hope that this video was helpful for you in understanding how to solve this kind of problem. So to stay updated with our uploads, subscribe to the channel and turn on the notification bell. So thank you for watching and have a very good day.